So, my dear friends, today we are going to discuss the disadvantages of hard water in boiler and what precautions should be taken to avoid the harm to the boiler. So, basically, you know that the important and large scale use of water in industry is for steam generation and it is used as a coolant. And to generate the steam at a very high pressure, the boilers are used. Modern boilers require high quality of water for the safe and efficient production of steam, and in that case, the quality of water plays a very important role. As we discussed in the previous classes, if the water contains different types of impurities are there, then they may cause the harm to the boiler, or they are called as the ill effects to the boiler. So it damages the boiler, it decreases the efficiency of the boiler, and therefore to generate the steam in the boiler, the quality of water is very important, and it's that water should be highly pure. It is free from the impurities. So depending upon the operating pressure of the boiler, the different quality of water is required. For example, for the low pressure boiler, we require the 25 to 50 ppm CaCO3 equivalent hardness water. So that is the permitted hardness for the boiler feed water. So accordingly, for the medium pressure, high pressure boiler, the quality of the water gets changed, and it is observed that for the high pressure boiler, the quality of water should be 0 to 10 ppm CaCO3 equivalent. So steam is required for power generation in thermal power stations, for uniform and controlled heating of reactors, for steam engines, and so on. So different designs of boilers are used in making steam of different pressures and temperatures, but water tube boiler design is more commonly used, and hence we are discussing today's discussion. We will stick to the water tube boilers. Generally, the lime soda process is used for the softening of water, and it is cheap, and it is applicable for the treatment on large scale. So we know that, friend, naturally rainwater is the purest form of the water, no doubt. But when that water come on the earth, on the water surface, on earth surface, then that flows to the different regions, and the impurities get enter into that water, and that water become not suitable to directly use it as for the steam generation, and therefore that water you should treat for the before feeding that water to the boiler for the steam generation. And if not, if you feed the water with impurities, and if you are not feeding the suitable water for the steam generation, then there are some troubles causes to the boiler. They are also called as the disadvantages of hard water on the boiler. So let us discuss what are the disadvantages of the boiler and how it affects the efficiency of the boiler. So dear friends, these are the disadvantages of the hard water on the boiler: priming and foaming, boiler corrosion, caustic embezzlement, and formation of scales and sludges in the boiler. We will discuss each and every disadvantage or ill effect with respect to its definition, causes, disadvantages, and prevention. So first we will discuss about the priming and foaming. So what is the priming? Priming is nothing but, as we know that in the boiler we generate the steam at a very high pressure. A violent agitation is there, and during this steam formation, there is a formation of small water droplets of liquid. They may pass, or they may go along with the steam, and that steam is called as a wet steam. So this process of formation of wet steam is called as a priming. Now what are the reasons for the priming? The causes for the priming are very high level of boiler feed water. If the level of water feed in the boiler, if it is not proper, it is more than the optimized level of water, then it may cause the priming. Presence of excessive foam, that foaming is there. High speed of steam generation, faulty design of the boiler. If the design of the boiler is faulty, then it may cause the priming. Sudden drop in the steam pressure, presence of considerable amount of dissolved salts, and the rapid cycles of cooling and boiling. If these things are happening there, then it may causes the priming of the in the boiler. How to prevent the priming? We should use the soft water for the generation of steam in the boiler with less dissolved solids. Maintaining low levels of water in the boiler. Avoiding rapid cycles of boiling and cooling. Proper design of the boiler by blow down operation or by blowing down the sludges and scales frequently, and fitting the mechanical steam purifier to avoid the priming. So these are the some remedies to avoid the priming in the boiler. Now we are going to discuss the foaming. Now what is the foaming? The foaming is nothing but it is the formation of continuous foam or bubbles on the surface of water inside the boiler. Now foam, it form on the surface of the boiler, and you know foam is formed when there is a soap come in contact with the water. So here question is that how the soap is in the present in the form in the boiler water, and how there is a formation of foaming takes place. So the causes of the foaming, the first is high concentration of dissolved salts in the boiler feed water. Then presence of an oil and alkalis in boiler feed water. So this oil and alkali which is present in the boiler together, they causes the formation of soap. How? Because you know why oil is nothing but it is the long chain fatty acids, and alkali, that is NaOH, it is formed in the boiler water during the steam generation at a very high temperature. So this long chain fatty acids combine with the NaOH to form the sodium salt of fatty acid, and that is nothing but the soap. So formation of soap decreases the surface tension of water in the boiler, and it causes the foaming. So presence of finely dispersed suspended materials also causes the foaming, helps to form the foaming. Violent agitation of the boiler feed water also causes the foaming. So these are the certain causes of the foaming occur in the boiler. How to prevent the foaming? First, you can add the anti-foaming agent such as castor oil, which absorbs the foam in the boiler and it avoids the foaming. Second, removing the high molecular weight fatty acids or oils from boiler using the coagulants such as sodium aluminate, by using mechanical purifier, and last by blow down operation. So these are the preventive measures to avoid the foaming. Now what is the blow down operation? It is nothing but frequently you have to drain out the water from the boiler, and you have to make up the, or you feed the fresh water in the boiler for the steam generation. Disadvantage of priming and foaming: it decreases the efficiency of the machinery, that is turbine blades. It decreases the life of the machinery. And third, actual water level cannot be judged due to the formation of foam in the boiler. Now we are going to discuss the second ill effect or trouble in the boiler, that is the boiler corrosion. Now what is corrosion? You know the definition of corrosion. Corrosion is nothing but the destruction of metal. Destruction of metal. So in the destruction of metal, you know the useful properties of metal get vanished or it get disappeared, and that metal is not more useful. So here also the boiler is made from the metal, and it undergoes corrosion, then there is maybe the risk of explosion of the boiler, and therefore this is very important ill effect considering the boiler. So corrosion of boiler metal is the serious problem and takes place if unsuitable water is used. The metal used generally for the construction of boiler is a mild steel, and hence you know iron has a more susceptibility towards the corrosion. So we are going to discuss the boiler corrosion which is taking place due to the use of unsuitable water. So these are the reasons. The first reason is the dissolved gases. In the dissolved gases, you know when the rainwater enter into atmosphere of earth, different gases get dissolved in the water. But here we are going to discuss the two important gases. One is the corrosion due to oxygen and corrosion due to carbon dioxide, because oxygen is a highly electronegative, and therefore it has more active towards the corrosion or towards the metal, and therefore it causes the more contribution in the corrosion. And CO2, which is acidic in nature, acidic gas, and therefore it also has a more contribution in the corrosion. Therefore we are going to discuss these two gases separately. Water usually contains about 8 ppm of dissolved oxygen at room temperature. As the water is heated in boiler, starts corroding. So dissolved oxygen reacts with the iron of the boiler to form rust. So see here friends, the reaction is given here, and it indicates iron react with the oxygen in presence of water to form the ferrous hydroxide, which is in presence of excess oxygen, it forms the rust, that is Fe2O3 H2O, that is rust. Now to avoid this corrosion, we have to remove the oxygen. So this is the preventive measure for the avoid the boiler corrosion due to oxygen. To avoid the corrosion by oxygen, the dissolved oxygen should be removed by adding calculated quantity of sodium sulfate and hydrazine. So see the first reaction, it is about sodium sulfite, it reacts with oxygen to form the sodium sulfate. Second reaction is sodium sulfite react with oxygen to form the sodium sulfate. And third is the reaction of hydrazine, N2H4 plus O2, it forms the nitrogen and H2O. So out of this, the hydrazine is the ideal chemical, suitable chemical to remove dissolved oxygen because the byproduct from here is the nitrogen, which is harmless. In the first two reactions, sodium sulfate is formed, and that sodium sulfate at high temperature undergoes hydrolysis to form the H2SO4, and in the acidic medium the boiler metal undergoes corrosion, and therefore first two chemicals are not suitable. Hydrazine is a suitable chemical for the removal of dissolved oxygen. Another method or way to remove the dissolved gases from the water is the by mechanical deaeration. So how we can remove here the gases from the water? The boiler feed water is introduced in the tower consisting of large number of perforated plates. The tower is heated from the sides with the suitable pressure provided by the vacuum. Because of large surface area of the plates in the tower, the oxygen is removed from the water, and this deaerated water is fed to the boiler. The water which is we get from the by the mechanical deaeration method is free from all types of dissolved gases, and it is suitable for generation of steam in the boiler. Second reason, dissolved CO2. If boiler feed water contains dissolved CO2, then it forms carbonic acid, hence corrosion takes place. The reaction indicates CO2 plus H2O, formation of carbonic acid, and this, in the presence of acid, the corrosion rate is increases. To avoid the corrosion due to CO2, we have to remove the CO2, and there are two methods are there as we discussed. One is the chemical method and second is physical method. In the chemical method, CO2 can be removed by adding suitable amount of ammonia. So reaction is given CO2 plus twice of NH3 plus H2O. We can also write here the ammonium hydroxide NH4OH, and there is a formation of ammonium carbonate. So in this way we remove the dissolved CO2 from the water. Secondly, the dissolved CO2 can be removed by mechanical deaeration method along with oxygen, as we discussed previously, by mechanical deaeration method. Another reason for the boiler corrosion is the hydrolysis of salt. If water contains the salts like MgCl2, calcium sulfate, etc., then they are hydrolyzed at high temperature and form strong acid. And this acid formation causes the boiler metal corrosion. So reactions are given. MgCl2 undergoes hydrolysis to form the MgOH twice, that is magnesium hydroxide, plus formation of HCl. Another is FeCl2 undergoes hydrolysis to form the FeOH twice, that is ferrous hydroxide, and this FeOH twice undergoes further oxidation to form the rust. So whatever the HCl form in the first reaction, it reacts with the metal of boiler Fe to form the FeCl2, and further FeCl2 undergoes hydrolysis. To prevent the corrosion due to acid formation in the boiler, the pH of the water is adjusted to 8.5 to 9. So these are the reasons for the boiler corrosion. What are the disadvantages of this boiler corrosion? The first is it decreases the life of the boiler. Second, it increases the maintenance cost of the boiler. And third, it decreases the efficiency of the boiler. These are the disadvantages of the boiler corrosion. It also adds the cost, maintenance cost, replacement cost of the machineries, and therefore corrosion of boiler is very harmful considering the life of the boiler and efficiency of the boiler. Third, so caustic impingement can be defined as it is the one type of corrosion, and it is a phenomenon during which the boiler material becomes brittle due to the accumulation of caustic substances. What is the reason or cause for the caustic impingement? Lime soda process, which is used for the softening of water, where the Na2CO3 is used. Water is passed through the Na2CO3 bed, and some quantity of Na2CO3 passes with the water, and that if that water which is coming out from the lime soda process is fed to the boiler for the steam generation, then at high temperature the Na2CO3 undergoes hydrolysis to form the NaOH. This hydroxide form comes in contact with the boiler metal through cracks or grain boundaries in boiler metal and forms sodium ferrite. So this sodium ferrite is actually brittle in nature, and it decreases the strength of the boiler metal. So this process will continually take place, and after some period of time the whole boiler body material becomes brittle due to the formation of sodium ferrite. So it decreases the efficiency of the boiler body material and it cannot be used further. So as we discussed, caustic embrittlement is actually one type of corrosion and it is caused due to the formation of two types of cell. It can be explained in this way also: formation of galvanic cell and formation of concentration cell. So galvanic cell, stressed part of the boiler metal act as the anode and gets corroded, while unstressed part of the boiler metal act as a cathode and it remains protected. Another way, the formation of concentration cell also causes or corrosion of the boiler and can be explained on the basis of this formation of concentration cell, where the higher concentration of NaOH in the cracks of stressed part act as anode and it gets corroded, while lower concentration of NaOH in unstressed part of boiler metal act as a cathode and it remains protected. So this is the reason for the caustic embrittlement of the boiler, and this especially occur in the high pressure boiler. Prevention: how you can prevent this? Use the sodium phosphate for water softening instead of sodium carbonate. Second, add tannin or lignin to the boiler water which blocks the cracks. Adjust the pH 8 to 9 of the boiler water. And last, add the sodium phosphate to the boiler water. These are the preventive measures for the boiler, for the avoiding the caustic embrittlement. These are the preventive measures to avoid the caustic embrittlement. Then another important ill effect, that is the formation of sludges and scales in the boiler. Now before going to discuss this sludge and scale with respect to their cause and their advantage disadvantage definition, first we discuss about why there is a formation of scale and sludge inside the boiler. So friends, we feed the water for the in the boiler for the steam generation, and in the boiler the steam is continuously generated for getting the desired pressure of the steam. At every moment when we add the fresh water for the steam generation, we are adding the actually some amount of impurities into the boiler. So what happens in the boiler? Water get evaporated, leaving behind the impurities. At a one point, the impurity concentration of the in the water it get saturated, and at that point the impurities present in the water, they come out from the water as a precipitate, and depending upon the nature of that precipitate, it considered or it called as a scale and sludge. For example, if the formed precipitate is soft, loose and slimy, then that precipitate is called as a sludge. And if the precipitate form, if it has a nature which is hard, sticky and strongly adherent to the inner walls of the boiler, then that precipitate is called as a scale. Let us discuss first about the sludge and then we will discuss about the scale. Sludges. Sludge is defined as it is a soft, loose and slimy precipitate formed within the boiler. Sludges are formed by the substances which have greater solubility in hot water but low solubility in cold water. The salts like MgCO3, MgCl2, CaCl2, MgSO4. These are the salts which causes the sludge formation. Sludges are generally formed at comparatively colder portion of the boiler and get collected at places where the flow rate is slow. Sludge can be easily removed from the boiler by wire brush. Disadvantages of sludge: sludges are poor conductor of heat, so they will waste a portion of heat generated. If sludges are formed along with the scale, they get deposited as a scale. They are very difficult to remove them. Excessive formation of sludges decreases the efficiency of the boiler. Sludges settle down in the regions of the poor water circulation, such as pipe connection, plug opening, etc., and hence thereby causing choking of pipes. Prevention of sludge: you can prevent the formation of sludge by using soft water, and second, by frequent blowdown operation. So we can avoid the sludge and scale formation by frequent blowdown operation. As we discussed, what is the blowdown operation? Frequently you have to release the water or drain the water from the boiler, and you have to feed the boiler with the fresh water, so we can avoid the saturation of impurities in the boiler filled water. Scales. Scales are hard deposits which adhere very firmly to the inner walls or surface of the boiler. So scales are so hard and adherent that they are very difficult to remove even with the help of the hammer. What is the cause for the formation of scales? The first cause is the decomposition of bicarbonate. At high temperature, that is boiling temperature, the bicarbonates present in the water undergoes decomposition to form the corresponding precipitate of the compound which is considered as a scale. For example, calcium hydroxide, calcium bicarbonate and magnesium bicarbonate. The reactions are shown here. Calcium bicarbonate undergoes hydrolysis to form the calcium carbonate precipitate. Magnesium bicarbonate undergoes hydrolysis to form the magnesium hydroxide. So magnesium hydroxide is a sticky precipitate, CaCO2 is a hard precipitate, and they act or they behave as a scale. Decrease the solubility of calcium sulfate. Calcium sulfate has a lesser solubility at high temperature. Hence, at high temperature, CaSO4 present in the boiler will precipitate as hard scale forming material. So, third reason, hydrolysis of magnesium salt. The dissolved magnesium salts undergo hydrolysis at high temperature, forming magnesium hydroxide precipitate, which forms the salt type of scale. The reactions are given how the magnesium salts present in the water causes the formation of scale. Magnesium chloride, magnesium sulfate, magnesium nitrate. The reactions are given. The product is magnesium hydroxide, which is a sticky precipitate. Last, the presence of silica. The small quantity of silica present in the water react with the soluble salts of calcium and magnesium, forming corresponding calcium silicate and magnesium silicate on inner walls of the boiler surface, and they are very difficult to remove. So these are the four causes for the formation of scale. Now what are the disadvantages of scale formation? Wastage of fuel. First, scales are bad conductor of heat like sludge, but scales causes the more impact on the boiler. They form an insulated coating on the metal surface. It affects the transfer of heat across the tube walls. In order to provide the steady supply of heat to water, overheating is done, and this causes the wastage of fuel. Second, danger of busting the boiler. Scales create a possibility of busting the boiler. Third, damage to the joints due to overheating. Boiler, there is an unnecessary strain on the plates and tubes of the boiler, and it causes damaging and weakening of the joints. Last, affecting the life of the boiler. Due to all these reasons, actually it affects the life of the boiler, and due to the overheating, metal of the boiler becomes red hot. This red hot metal forms iron oxide with the atmospheric oxygen, and it undergoes corrosion, and it forms the rust, that is Fe2O3. So formation of sludge and scale, it affects the overall life of the boiler, it affects overall efficiency of the boiler, and therefore to have the smooth operations, smooth generation of steam in the boiler, we have to use the suitable water for the steam generation, so that we can avoid these troubles in the boiler, that what we discussed. How to remove the scale? If the scales are loosely adhered, it can be removed with the help of the scraper or piece of wood or wire brush. If the scales are brittle, then they can be removed by giving thermal shocks. If the scales are hard and sticky or adherent to the inner walls, then by use of suitable chemicals, the scales can be dissolved and removed. For example, calcium sulfate scales are removed by adding EDTA. Since calcium EDTA complex is highly soluble in water, CaCO2 type of scales can be dissolved by using 5 to 10% HCl. So these are the different remedies, ways to remove the scale from the boiler. Prevention. We can prevent the formation of scale by using the soft water, addition of sodium phosphate to the water. Third, by frequent blowdown operation. Last, adding sodium aluminate to trap the scale forming particles in the boiler. These are the preventive measures to prevent the scales. This is the comparison of sludge and scale. We already discussed about the sludge and scale. It is a very important point to better understand scale and sludge, their comparative points. So you can go through this and you can better understand the scale and sludge. So this is from my side, dear friends. That is the ill effects of water on the boiler during the steam generation. If you have any doubt, you can comment me, and if you like this video, then suggest your friend and subscribe my channel. Thank you very much.